Hello everyone. So we are still learning about ellipses. It's 8-2, so a few more examples today. So let's start off with one with graphing, and we'll try to work backwards. So you'll see a graph, and from there we'll try to derive an equation of that ellipse. So what I see is this graph here. So 1, 2, 3, 4, 5. And this is -2. So 5 and -2 is the center point of this ellipsis. And this is how it looks like after it's not perfect. You know, I'm not the best one. I can't draw sometimes. Anyways, so that's what I see. So we need to write down the equation. So first thing, you know this equation should have x, this would have y, it would be equal to 1. There would be numbers under each one. Okay, let's try understanding every single detail and let's try substituting these numbers in the equation. First thing I need h and k. So we already know h and k is here, so 5, it's x minus 5. Remember, we take the opposite, so -2 would be +2 here, square. Halfway through. Now we just have to find radius on each axis. Now, but how? Okay, basically it's just finding the distance on both. So let's look at the x-axis first. So how far you go on the x-axis. This is one of the vertices and this is the center point. So how far we go on the x-axis? So we go 5 units. So it means under x, it would be square of that number, which is 25. What about the y-axis? So how far you go on the y-axis? So we go 2 units. Remember, we take the radius, so 2 squared would be 4, and yeah, that's pretty much all. So that's how we work backwards. Okay, so that was my first example. Now, next example. This equation is going to look slightly different. So normally, you know, ellipse equation is equal to 1, but this time I have something like this. It's 9x to the second plus 6y to the second, and it's equal to 36. That's what I have. Okay, so I need to change this equation to standard equation of ellipse, which is normally equal to 1. So think about this. So this number on the right side has to be equal to 1, right? What would you do to 36 to make it equal to 1? So that would happen if I divide this by 36, isn't it? So since it's an equation, if you divide one side of the equation by that number, so you have to do same thing on the other side as well. So if I divide this whole equation by 36, number on the right side would become 1 halfway through. Now rest is just simplifying. So 9, 36, this is 4. 6, 36, simplify to 6. So that's my standard form of the equation. Now, if I ask you for all of those details like vertices, co-vertices, foci, and h and k, can we do that? For sure. All right, so what's h and k? What's the center point? Since there's nothing attached to x and y, so it would be 0, 0. Okay, which one is my major axis? Major axis is y because the bigger number is under y. So it means your vertices would be on the y-axis. So we have 6, which is a square. So if I take square root of this number, that would be the a value. So square root of a, I would say it's almost like 2 point, let's just say 3. So since these vertices are on the y-axis, so I would write it as this, co-vertices. Co-vertices, I have it on the x, so this is 4, so the b value would be 2, and since it's on the x, so it would be plus and minus 2 comma 0. Foci, it's c squared is equal to, you know, a squared minus b squared, which is 6 minus 4, c squared is equal to 2, c is equal to square root of 2, and you know foci always going to be on the major axis, so this would be 0 comma plus and minus radical 2. Here you go. All right, so one last example. So let's look that up. Again, that's not going to look like normal ellipse equation, but we have to do something to make it into normal looking equation. Okay, first let me write down the equation because there's something else you need to understand. Let me just change these grid. Oh, wait a second. That's not what I want. Wait a second. I don't want... Okay, let's just forget about this. Anyways, This is how normally ellipse equation looks like, right? This is y, this is minus k square b square. Let's try understanding this equation. Okay, on the right side, what I see, it's always 1. So this h and k is in parentheses, and this whole part is actually, the whole part in parentheses is a perfect square. I hope you understand this term. When I say perfect square, means the binomial itself is a square, means that has square on the top, so that makes it a perfect square, okay? And then there's number under each one, okay? So what the example I'm going to show you here, that's how it originally looks like, which is nowhere close to what I see up here, right? First thing, what I would do is I have to make x and y as perfect square. Now this is where you have to follow that strategy of completing the square. So I hope you remember getting magical number, adding on both sides. So that's what we're going to do here. So we're going to be using completing the square method. Okay, how do we do that? First step, you need to group x's and y's. So I would group x's first. So 9x to the second and minus 18x. I'm just going to group these. Okay, do we have any y terms? I have 4y to the second and 8y. And there's 23. So basically, if you look closely, this equation has 3 different parts. A constant, y's, and x's in there. But none of these x and y's are perfect square. But we have to make it a perfect square. How? So let's look that up. First thing, the number on the other side has to be 1. So the other side number has to be a constant. So it would be easier if I take this number and put it on the other side. Now I have, this is what I see so far. And if I move 23 to this side, it would become positive. Almost there. Now we are trying to make perfect square for each, like x and y both. So this x, this y. So for that, I hope you remember we factor out the a value. So what's the a value? So a value is 9 for this x part. This becomes x squared. It's 2x. And I would leave some room for our magical number. Now let's move on to y's. What's your a value for y expression? It's 4. Factor that out. Y to the second. This is 2y. And I would leave some room. And it's equal to 23. All right, we're getting there slowly and steady. Now we need to make each parentheses into a perfect square. So get a magical number. How do we get magical number? So it's the b value, cut it in half and square. So the b value here is 2. We don't take sign. If you want it, you can do that. Because now it's not going to make any difference because eventually it's going to get square and still it's going to be positive. Okay, negative 2 divided by 2 and square would be 1. Because half of 2 is 1, square is 1. Okay, same thing here. So 2 divided by 2 is 1, square is 1. Okay, this is something you need to understand. You just added something to one side of this equation, right? So in order to keep this equation in balance, you have to do same thing on the other side. Okay, so what did I add on this side? So technically, I added 9 here. And I added 4 here because don't forget, you need to distribute the a value first to see the actual number. So technically, I added 9 and 4 on this side, which eventually becomes 13. So I have to do same thing on the other side. Let me erase this on this side because I need room to write the other number. So I would add 9 and I would add 4 on this side. Okay, almost there. This is 9. Now this becomes a perfect square after finding the magical number. So what is a perfect square? So I hope you remember. Let me erase this part here first. Okay, so we take first number from the first term. So take square root, it's x. So the second number comes from the last number, square root of that, it's 1. We borrow the sign from the middle term, it's negative, and I would put square. That's the shortcut. Second part, I have 4. Okay, we get first term from the first one, take square root, it would be y. We take second number from the last one, square root of 1 is 1. Borrow the sign from the middle one, it's plus, and there's a square. And what's the number on the other side? 23 plus 9 plus 4 is 36. Okay, almost there. Now, this still doesn't look like actual equation, actual or standard ellipse equation. So, on the number on the other side has to be equal to 1. So, what would you do? So, I would divide by 36. Simplify. So, first one simplify to x minus 1 square over 4. Second one, and here you go, that's my equation. And finally, if I ask you to find all these details, can we do that? Yes, we can, because everything is already there in the equation. What's my h and k value? So negative 1, it's going to be, we take opposite, so it's 1 and negative 1. What about my vertices? So you can make a table in order to figure out the rest, but you know what? I'm not going to ask you for all of these details, because I guess this is already enough. Like we already went through a lot of these steps, so I guess this is all good. So if you could just figure out the equation for this type of problem, you're perfectly fine. That's all you gotta do. All right, guys, thank you for watching. Bye bye.